Hello everyone, my name is Paccini and I will give an overview of precipitation variability and extreme events for this project. First of all, precipitation is one of the main components of the water cycle that not only determines weather and climate patterns at different scales, but also supports ecosystems, agriculture, and human life. The amount and timing of precipitation is very important and can vary greatly from year to year, which can lead to the occurrence of extreme events such as droughts or floods. So it is important to make a distinction between these two concepts, and I will illustrate that with these plots. So what we have here is information of daily precipitation for a given region, and the lower plot just shows a slice of this data. And we can already notice that precipitation varies temporally. So we can see, for example, that there is an increase of precipitation in the months of January through May, and a decrease of precipitation towards the months of September and November. We can also note here that values between 0 and 20 millimeters per day can fall into the normal range, because if we look here in the histogram plot, we can see that these values show high frequencies. So actually, this is within most of the precipitation data. However, if we look at this event of 80 millimeters per day, and we compare this in the histogram, we can see that this falls far from this red line, which shows the 99th percentile, and which actually means that this value represents much less than 1% of the total data. So in this case, we can say that this is an extreme event, and it is precisely this type of events, those that have more impacts over human and natural systems. In order to identify objectively the extreme events, there are several methods, and as I just showed in the previous slide, we can just set a relative threshold like the 90th percentile and say this is a very wet day, or we can set an absolute threshold, let's say 10 millimeters per day for a heavy precipitation event. For this project, we will give you a list of indices that will basically describe their intensity and duration of events. So you can choose from this list, or you can also propose your own index. To end this part, I will give you some food for thought about open questions of this very wide topic. So for the present, we have that it is very challenging to predict precipitation and especially extreme events. But we also lack of a deep understanding on the mechanisms behind these processes. So the availability of new observational sources, as well as the advancements in modeling and the use of new techniques such as machine learning techniques, are very useful to tackle these questions. In a similar way, we can use this new information to address questions for the future climate. So it is also very challenging to represent precipitation in conventional climate models. So it is very uncertain how precipitation will change under global warming scenarios, and in particular, what is the role of the human activity, for example, the land use. So now we move to the datasets that you're going to use in the project, starting with the CHIRPS dataset. So this product actually blends satellite information with in situ observations. It is daily precipitation that comes at a grid spacing of about 25 kilometers from 50 south to 50 north. So the coverage period that we have is from 1981 to the present. Since we are relating precipitation also to changes in vegetation, we need to use information for this variable. So in this case, we are going to use the normalized difference vegetation index, or NDVI, which is a product by MODIS. As you can notice, these are different products, so very different spatial-temporal resolutions. For example, we have that the output for MODIS is a 16-day means with a grid spacing of 250 meters. However, we have already pre-processed this information for you, so you are going to use the MODIS dataset at the same spatial resolution as the CHIRPS datasets. As for the temporal resolution, you have to resample the daily data from CHIRPS to the 16-day means, so you can compare both datasets when you are doing your analysis. Finally, if you want to go a bit further, assessing the impacts of precipitation variability and extreme events on agriculture, we are providing the information about cereal production, which is a product that was made available by the World Bank, and you can have access to this, to some specific grains by country and per year. So these are all the data sets that you can use, but of course, depending on your research question, you can also use data sets from other projects. So these are all the ingredients for the project, which basically aims to understand the relationship among precipitation, vegetation, and extreme events.